Hi, this is Miss Dove bringing you the video about volume of rectangular prisms, and this is part 2. So our goals for this video are to solve real-world problems involving the volume of right rectangular prisms with fractional and decimal side lengths. Before we get started, let's make sure we remember how to find the volume of a prism. So in the last video, we learned that you multiply length times width times height. You can also call this the area of the base. You just have to remember that to find the area of the base, you multiply the length and the width at the bottom of the prism. So we're going to do 3 times 8, times 6. And you can multiply in any order. I'm going to multiply here first. 3 times 8 is 24. Then you bring down your 6, and 24, times 6. That is 24. Carry, that's 12 plus 2 is 14. So my final answer is 144m, and remember it's cubed because you're multiplying 3 units together. So just a reminder what we just did, but here's also another visual to find the volume of a rectangular prism. You multiply the length, the width, and the height. So here's practice problem 1. I challenge you to pause the video and try it. This says a brick is 22.5 centimeters long, 10.25 centimeters wide, and 6.5 centimeters high. What is the volume of the brick? So this is going to be the same type. The only thing that's different is that we have decimals. So we're doing 22.5 times 10.25 times 6.5, and you can multiply in any order. So I'm going to start here, and I'm going to put the number with more digits on top, and I will consider the decimals at the end. So I'm doing 25, that's 10 plus 2 is 12, that's 0 plus 1 and 5. Put my placeholder, that's 10, that's 4 plus 1 is 5, that's 0 and 2. 2 placeholders, 2 times 5 is 10, 2 times 2 is 4 plus 1 is 5, 0 and 2. And now I add everything up. And I have these digits here, but I have to consider that in the problem, 1, 2, 3 numbers are behind the decimal. So in the answer, there should be 3 numbers behind my decimal. I'll multiply that now by 6.5. Because I was out of room, I did my multiplying off to the side, and I got 1,499.0625, and that's going to be centimeters cubed. And you're always welcome to check your answer with a calculator to make sure you didn't make any mistakes, because that's a lot of multiplication. So practice problem 2, again, I challenge you to pause the video and see if you can figure it out. So this says the back of Daisy's truck is shaped like a rectangular prism with a base area of 5 square yards and a height of 1.2 yards. So I'm going to draw just a quick little, if you ever want to draw a 3D prism, you overlap the front and the back, and then you connect all the corresponding corners, and you have yourself a prism. So the base of it, they told us, okay, is 5 square yards. and then the height is 1.2 yards. So the volume, we'll do the base 5 times the height, and because of space, I'm going to do it off to the side. That is 6. 6 yards cubed is the amount of space in the truck. This says Daisy has the back of the truck filled with gravel until it's 75% full. The gravel costs $25 per cubic yard. How much does Daisy pay for the gravel? So first, we need to figure out what is 75% of 6. And we learned how to do this a couple units ago. So remember, is means that you need a equal sign. This is what I'm looking for, so I'm going to call that X. We're going to be doing 0.75 times 6, because remember, to calculate with a percentage, we change it to a decimal. So I'm going to do 0.75 times 6, and that is going to be 4.5. So what that means is she's using 4.5 yards cubed of the amount of truck. That's the amount of space that she's filling it up with. And now we're going to multiply this by 25 to tell us the total cost, because each cubic yard is $25. So 4.5 times 25 comes to $112.5, so that's 50 cents. $112.50 is our final answer for how much does she pay. Remember, she filled it up 75% full. This would be 100%. So this is 75%. And we multiplied that by the cost of 1 cubic yard, and that gave us our total at the bottom. So before you leave, make sure you feel like you can solve real-world problems involving the volume of right rectangular prisms with fractional and decimal side lengths. Thanks for watching.